Welcome to the third lesson in the Transformation Unit. Lesson 3.3 discusses rotations, another rigid motion. In notation for rotations, you'll notice that it's a lowercase r, which is to keep it separate from the reflections, which are in uppercase R. Also, in the parentheses, subscripted, are the angle measure that's being rotated and the point about which it's being rotated. So if we look at this example down here, where triangle ABC is being rotated x degrees around point P, the x degrees is here, point P is here, giving us triangle A prime, B prime, C prime. Okay, keep in mind, rotations are also called a spin or a turn. They're rigid motion, which means they keep the same angle measures and the same side lengths. Okay, let's take a look at a rotation of a triangle around point P, 75 degrees. What we're going to do is use a protractor, and we are going to draw very light lines from the point of rotation to each vertex. And then after we draw those lines, each one of them, we are going to create a 75-degree angle. So lining that up with the line from vertex Y to P, I have a 75-degree angle out here. And I'm going to create a line from P, not all the way out there because I don't have to have it that long. In fact, I only need it to be this long. So I want those distances to be exactly the same. So I'm going to measure that, and that's going to be just a little bit less than half an inch. So out here at point P, I will measure this just a little bit less than half an inch. So it's going to be right there. And that is going to be my Y prime. Okay, now I'm going to get this out of here, and I'm going to do the same thing with Z. So right here, I'm going to draw a very light line from point P to vertex Z, and then I'm going to use that to create a 75-degree angle. So lining that up just so gives me a point right out here, and I can draw my line from that point P out there, but I only need the distance from Z to P. So lining that up, it's going to be about 3/4 of an inch. So let's see, that's going to put it right about here. And that is going to give me Z prime. Okay, and I'm going to kind of get rid of that line a little bit because I don't need that either. And finally, X prime. So I'm going to make my line from point P to X, and then I'm going to use that line to come up with a 75-degree angle right out here, and lining that up. It's going to be about like that, and now we'll measure it, and it looks like it's just a little bit more than an inch. So we'll measure this at just a little more than an inch. And that is going to give me X prime. Now I'm going to get rid of these lines and connect my points. And I have my triangle rotated 75 degrees around point P. Okay, now let's take a look at some coordinate geometry and some rotations that go with this. So we have a 90-degree rotation. So from this point to this point, keep in mind that all of your rotations are counterclockwise unless you're told otherwise. And then we have a point that goes 180 degrees around the origin, and we have a point that goes 270 degrees around the origin. These all have a pattern. So if we take a look at what this point is, and this one is 1, 2, and then we look at this one, and this one is negative 2, 1, we can see that the x and y are flipped and the y is negative. So we have negative y and x. Okay, for a 180 degree rotation, we start at 1, 2 again, and then down here we have negative 1, negative 2. X and y don't flip, but they're both negative. So we'll make negative x and negative y. And then finally, for the 270 degree rotation, we have point 1, 2. And then over here, we have 2, negative 1. So the x and y are flipped again, and this time the x is negative. So it's going to be y, negative x. Okay, let's go ahead and use those to do a couple rotations. So in the first one, we have a 90 degree rotation. I have already put my original images on here, my pre-images. So if you'd like to pause the video to do that, this would be a good time. Okay, so keeping in mind that the pattern is negative y, x for this one, we're going to look at our points. So we have negative 4, 7 for our first point. We're going to flip those around and make the y negative. So negative 7, negative 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Okay, and then we have 0, 8, so it's going to be negative 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. And then we have 2, negative 1, which is going to be 1, 2. Right up here. Now we can go ahead and connect those points. And we have our rotation. This one's 90 degrees around the origin. Okay, let's take a look at 180. Okay, so for this one, we have negative x, negative y. So we're just going to change the signs. So the first one's going to be 4, negative 7. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So it's going to be right down here. The next one is 0, 8. So it's going to be 0, negative 8. So that one's going to be right here. And then 2, negative 1 is going to be negative 2, positive 1. Negative 2, positive 1. And we can go ahead and connect those points. And we have our second rotation, 180 degrees around the origin. Okay, last one. So for this one, we are looking at y, negative x. So we are flipping them and changing the sign of the x. So this is going to be 7, 4. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. And 8, 0. So that one's going to be right here. Whoops, right here. And negative 1, negative 2. So negative 1, negative 2. It's going to be right down here. And we'll go ahead and connect those points. And we have our 270 degree rotation, and it is just that easy. Okay, let's take a look at finding a sequence of reflections that results in the same image as a rotation. So I've got JKLM is rotated around point T to give us XWZY, not necessarily in that order. So what we can do is draw a line of reflection. We're going to put it kind of close here. Here's one line of reflection. This would go over here. And so then in order to figure out where the other line should go, we can go ahead and reflect this across, keeping in mind that we want perpendicular and we want it to go the same distance. So this one is going 1, 2, 3, 4, 5 eighths. So we're going to go 1, 2, 3, 4, 5 eighths. Okay, so we've got a point right about here. Then we're going to do the same thing with point J. So point J is lining it up on that line. Okay, so point J is about a ½ inch. So we're going to go about a ½ inch right here. So we've got another point right here. And then point L is also about a ½ inch. So we're going to go almost a ½ inch right here. So here's point L and point M. And to make this perpendicular, I am lining this line that goes right through here up on the line of reflection. And so that's giving me a 90-degree angle or a perpendicular line here. So here's line M, and this one is about 7/8. So we're going to go this way about 7/8, and it's going to be right here. Okay, we can go ahead and connect those. And that's going to be our first reflection. Now, to find our second reflection, we need another reflection line, but it has to be right in between here. It has to be in the middle in order for this figure to be reflected over and land exactly right here. So what we are going to do is connect these points. Okay, and then we're going to figure out where the midpoints are. So right here, right here, right here. So it looks like we're going to have a line of reflection that goes right through there. So our other line of reflection is going to be right there, and then this will flip over nicely right there. So the first one you can kind of estimate. The second one is going to be from the midpoints of your perpendicular lines that go from your vertices and your point of rotation. Okay, now let's take a look at a theorem. Theorem 3.2 says any rotation is a combination of two reflections, just like we did here, two reflections across two lines that intersect at the center of rotation, which is exactly what ours did. The angle of rotation is twice the angle formed by the lines of reflection. Okay, so from here to here, that's going to be twice this angle right in here. Or if you want to look down here, we've got an angle of rotation right here from A to B around point P. Okay, this is X number of degrees from here to here. And then looking at this one, that same rotation would be right here. But we've got A reflected over line M, that's A prime, and then reflected over line N, which is A prime, double prime, which gives us B. And this angle between these two lines of reflection, if you look right here in the orange cloud, this angle is half of X, and X degrees is the number of degrees between the entire rotation. Okay? So see what you can do with that. If you have any questions, make a note of them and you can ask me in class. See you later.